Record. Okay, I think we're going. Hi, my name is Chamblee, and this is my first Excel report. Here's my info. I don't have a LinkedIn, so I just put my email and name. And this is for Module 1. Let's start with relativity and number density. So you can see here on the graph, we just found the speed for Earth's rotation, Earth's orbit, solar system orbit, the Andromeda galaxy speed, the Milky Way orbit, and the local group speed. One thing that I found interesting about this is while 1,000 miles per hour or 1,037 miles per hour might seem like a lot to us, it's really nothing compared to the Milky Way or the local group speed or even just Earth's orbit. And on the graph, we can see how really small the Earth's rotation speed, even at 1,000 miles per hour, is at 0%. In terms of something that I found interesting on the website that was shown to us, I'm a gamer, and I thought the fact that Minecraft world is the size of Neptune was really cool. To think that something that is housed on a computer is as big as a whole planet is kind of mind-blowing, and something that I can play on as well, which was kind of crazy. Back to the pi and bar graph again, we get another example of how low in terms of speed the Earth's rotation is. And why we don't feel this speed is because the movement is constant. The movement being constant means that without any change in speed, we don't feel like we're actually orbiting or rotating. We feel like we're standing still. These large numbers like the Milky Way orbit, local group speed, etc., is why the scientific notation or the E's are used. Another thing that I learned here was that speed is all relative to what you're comparing it to. We're moving pretty fast if you compare anything to the Earth's rotation, but if you compare it to the local group speed, it's not very fast. So let's go on to misleading data. Scroll to the top here. In terms of the first graph, which is very relevant for today with all the politics and fake news going on, we see how the first graph kind of lies to us. We put in this graph the unemployment rate percentages, and at first look on just this graph over to the left, it doesn't look like a big difference, both at one at 5.2, one at 5.8, and honestly, if you wanted to round up in the 100th place, it would be 5.2 as well. But this graph tells a different story. It makes it seem like Clinton had a much higher unemployment rate percentage than Bush did, and that's because on the vertical axis, this graph starts at 5.1750, making Bush seem a lot lower than he actually was. If you look at the graph that's not really trying to lie to you, at 0.0 at the start on the vertical axis, you actually see that they're very close together. Same is true for the bowling scores. And we just did the bowling scores for Diana, Hilda, and Emily. Starting at 105, it makes Emily, her numbers seem a little bloated, as if she's a lot better bowler than Hilda or Diana, but starting at 0 again, you see that they're actually pretty close together. These types of graphs or pie charts can be used for multiple reasons. The main one would be to mislead you and to get you to believe something that's not honestly true. Often reporters or people who make these kind of graphs that are trying to mislead you have a bias or a ulterior motive, and that can kind of come to show here. Let's look at the two pie charts now. On the left, we have the money in U.S. dollars, millions spent, and if you look, the city looks like the city's spending half. That's what the pie chart wants you to believe on the right here. But in reality, if you put the numbers in like we did here from the chart to an actual pie chart, you see that they're actually spending 65%. And that 65% from the city is most likely taxes, so it means you're paying more than the chart initially let on. This could be a business who maybe they're funding their new arena, and they want to make you think that they're splitting it 50-50 with you, but in reality, you're paying more than they are, which is unfair. And then you look at percent of sales here down with the CARTIA graph on the right. While it says 4.5, that looks a lot bigger than 4.5, and this pie chart on the left confirms that. CARTIA 4%, that's just a sliver right there, but it's a whole big space in the middle. We looked at these numbers right here. That actually that circle is about 13.72%. We did the math. Here you look at we took pi, we times it by 0.5 times 0.27 to the second power to get that number, and then we took, again, we're just doing circumference of squares here. Took the circumference of the big circle up at the top, and then the little circle right here, 4.5, and then of course to find the percentage, we just divided the top by the bottom, or the bottom by the top, sorry, this number by this, to get that 13.72, which is the orange circle, which is the exact same size as the CARTIA circle. So you can again see some bias by maybe a company wanting to make their sales seem bigger than it actually is. We looked at the information from 3 causes of bad data in survey research, and you can see these kind of in action with misleading data or biases. And then obviously, if one of these charts were to be a survey, you could also see the bias of leading questions or questions that are meant to get wrong answers or a poor sample size. So there's a lot of ways people can mislead you. Let's go on to the third one, population and probabilities. Here we took the whole American population and we looked at how many of them were obese. 29% is obese, 10.5 has type 2 diabetes, 32.7 has high blood pressure, and then 90% of Americans with type 2 diabetes are classified as obese. 90% have high blood pressure, and 86% of obese people have high blood pressure as well. 81% of American type 2 diabetics are obese with high blood pressure. Took all those numbers, put it on the left side of the graph here. And you can see we took each number, and you see type 2 diabetes, and there's that little horseshoe that means and. With obese people, that's 31.1 million. And down the graph it goes. This is an effective way of showing how many people, and with the Venn diagrams it shows us as well, how many people are just obese, and then how many people are obese and have high blood pressure or type 2 diabetes, etc. Okay, the formulas here, obese minus type 2 diabetes and obesity minus obesity and high blood pressure minus type 2 diabetes and obesity and high blood pressure. We use these formulas in the middle to get the true number of people that are just obese and not having another type of illness for the Venn sections over here. So it comes out to be actually just 10.3 instead of that 95.5. That 95.5 of people obese include people that also have type 2 diabetes or high blood pressure. So we see this illustrated in the Venn sectors. 10.3 people million are obese, 0.3 just have type 2 diabetes, 22.4 people, that's millions, just have high blood pressure, and in the middle here you can see where they overlap. 54.1 million people have both obesity and high blood pressure, meaning it's pretty common, way more common than just having obesity or high blood pressure. And in the middle, 28 million people have all three. See these in percentages here, which makes it easier to read and have a perspective. 16.4% of Americans have obesity and high blood pressure. Comparatively to the control, 63.1 people don't have any of these three diseases. Thought it was really interesting, the probability that someone is obese, that they're going to have high blood pressure or type 2 diabetes or just both. It's much more likely that when you're obese, you're going to have high blood pressure. So these states over here in this map, which shows you the amount of adult obesity rates, these states in purple are most likely going to have high blood pressure rates and type 2 diabetes as well. Just shows how unhealthy they are. Another interesting thing that I saw was that most of the purple states, which means high adult obesity rate, are in the South, with the exceptions of Iowa and West Virginia. Every southern state, of course Florida, but Florida's weird, is red or purple, which are the highest too. And this is obviously kind of a cultural thing, Southern hospitality and fried food. But you see out west, they're all orange or yellow, Colorado being the healthiest state, along with the District of Columbia and Hawaii in terms of adult obesity rate. Found that very interesting, but I guess it kind of makes sense. Okay, let's move on to measures of center. Here we have the Army recruits' BMIs. This is without them sorted. Here is with them sorted. And then the random mall shoppers' BMIs, sorted and unsorted. We see the measures of centers here with range, median, mean, standard deviation, and coefficient of variation. To find the median, of course, I'm just going to take the two. And using Excel, it'll calculate the median for you. To find mean, of course, they'll put average into Excel and it'll calculate it for you as well. Range I did manually. It's just the top minus the bottom, the highest number minus the lowest number to get your range. And then standard deviation and coefficient of variation done by Excel as well. We didn't do this in Excel. We took F21, which is the standard deviation, and we divided it by the mean to get your coefficient of variation. Same on this side as well. See with the Army, something talked about in the question, the 5-sentence questions. The Army recruits much more uniform compared to their mall shoppers. It's obviously due to the requirements to be an Army soldier. To be a recruit, you have to be in shape, have to be fit, able to do certain tasks. To get to the mall, you just have to be able to walk or drive. So that means that Army recruits are going to have a much more likely chance of being within one standard deviation, which we see in this bell-shaped curve here. That 68.2 is probably very true of Army recruits, if not higher. What we see with the box and whiskers graph is that the random mall shoppers BMIs, they have an outlier here. And that outlier is 72.5 in red here. This outlier skews all the range, median, mean, standard deviation, coefficient of variation. Basically the measures of centers. It skews that and it makes it no longer representative of the entire group. So it makes the outliers data unable to use. So we didn't do a bell-shaped curve for it. We did it for the Army. Here you see the percentage chances that they're 1 deviation away, that they're 2 deviations away, and 3. On the right here, we took these percentages and added 2 to each one, thus getting the numbers over here to your normal distribution. And then that, of course, correlates onto the BMI scores of the people. That bell-shaped curve it's not going to be a bell-shaped curve for the random mall shoppers BMIs due to the fact of this outlier. So again, that skews the data. Of course, the Army without an outlier has all the usable data. All the mall shoppers don't, as we talked about earlier. All right, let's go ahead and move on to the 5th one, investment, sales, and profits. Talking about Elon Musk's flamethrower company. We just looked at the profit here, putting in each sales and profit number. Here we just took 500 with the formula 500 times the amount of sales, which is X. So 500 times 20 is going to be 10,000. Put that formula in Excel and just drag. Of course, it gives you the chart. Here's the chart here with the profits. But with this profit, we use another formula, 6.212 x to the second power minus 1200x minus 12,000. And that's to get your margin of profit. It's a much truer a graph in terms of how much money a company is actually making. As you see here, they start off 0 sales and negative 1,200 profit. And then as they get more sales, they actually lose money until they hit rock bottom around 100 here at a negative 59,080. Once they hit the bottom number, the bottom dollar, they start to rise until they hit a break even right around a little before 200. but we'll say 200 just for even sake. At 7,280, they're starting to make a little bit of profit. And then, of course, the highest profit here at 300, which is not seen on the graph, but it just keeps going. There's a little arrow there to show the 300, which is profits of now a whopping 197,880. This is really interesting. Obviously, the connection between the smallest profit value on the table and the lowest. To get to that smallest profit value, you have to hit that rock bottom. As the popular mantra goes, you have to spend money to make money, and that's shown pretty clearly on this graph. Let's go on to the investments. With interest levels, there's 3 types of investments shown here. You have simple, annual, yearly, and a continuous compound, each one yielding higher interest than the last. As you can see, there's different formulas. One is just the principal investment with 1 plus the annual interest rate times the time. Put that formula into here as we see up here. Lock in those numbers with the dollar signs, stay constant except for time, and then you get the number. 11 years, it blossoms from the first year investment of 5,300 all the way to 8,300. And then, of course, here with annual, yearly, it's a different formula. Instead of rate times time, you have rate divided by the number of times compounded per year to the number of times compounded per year times time. And then this one is going to be principal investment times E, which we'll talk about in the second module, to the annual interest rate times time power. Of course, these are going to yield different results. They're slightly different, but they're pretty comparable when compared to the simple. One yields 9,490.49. The other is 9,673.96, which the company owes back. One of the questions asked was if I was Elon marketing manager, which investment option would I offer and why? I'd probably offer just a simple one. The company is not struggling for money at the moment. They're making a pretty hefty sum at 197,880 just from flamethrowers, which is a pretty niche market. So I would be just safe, play it safe, play the simple. It's a straight line. It's going to yield less interest levels. Should we misspelled interest here? And that's what I would do in my own opinion. Elon, to sell, to make a profit of 90,000, you only have to sell 251 flamethrowers, which again I think supports my claim. That's not a lot of flamethrowers, and if you're selling the flamethrowers at such a high price, you're not really looking for a whole lot of investment at the moment. So I think simple's the best option. Let's go to the 5-year financial plan, the last one, down the home stretch. I just put a mean salary of about 72,500. I don't know exactly what I want to do for a job yet. I'm still young, relatively. So I didn't put anything in terms of picture. I wanted to leave that open, but I just picked kind of the mean salary for someone living in Little Rock, or the Central Arkansas area, with about $500 in reimbursements. And then we totaled up here: groceries, credit cards, eating out, gas, entertainment, clothing, taxes, maintenance, repairs. I kind of made it my own a little bit while including the necessities. Stuff that I think I'll be spending, along with stuff that I know I'll be spending. It came out to a monthly income of $6,083 with a monthly expenses of $6,000, leaving me $83.29 of overhead. To be honest, I'd like a little bit of a bigger difference, just because you never know what problems are going to arise, and if you're going to need some extra money to I don't know, pay extra medical bills or utilities or maintenance or repairs. You never really know. We did the tax here. I'll show you the formula right here. My tax bracket was 22% and 6.9%. So we took 0.22 plus 0.069 times the sum of C12, C12, of course, was the salary. Let's go back to this. Divided by 12, which is the amount of months per year, to get 1,746 taxes per month. It's a lot, but win some, lose some. Here on the chart and the bar graph here, we can see that I'm paying a lot for medical bills, mortgage bills, savings, and of course taxes, while eating out, clothing, entertainment come in at 0%. It's going to mean that they're below 1% or closer to 0. So they have very small slices of the pie. Here again, we kind of see how low the non-essentials are, whether it's groceries, eating out, entertainment, clothing, internet, TV, while the necessities like medical, mortgage, savings, taxes are going to be higher. For mortgage, I just looked up the regular house price, and I think I did a 30-year mortgage to calculate the $939. Let's go to time management. Oh, and just a sample picture of a nice house that I thought in the Lark area, and then a Honda Civic. It's fuel efficient. Click down on accident. It's fuel efficient, saving me money on gas. Hopefully only 2 fill-ups a month would be preferable. That's what I average about right now. Time management, 168 hours a week. So that's where that total comes from, which is the sum of all these. 56 hours of sleep, and that's 8 hours a night. So recommended amount, I believe. 35 hours of work. Hopefully I'm close to the 40 hours. You obviously don't want to overwork yourself and leave time for stuff like friends, family, and of course Netflix. See yard work, gaming, chores, just the regular stuff in a day. Here the pie chart, we kind of see the split here. 32% sleeping, 21% work, the necessities. And then, a good 11%, 8%, or 6% with family and friends. Some relaxing time with gaming and Netflix, and then yard work kind of molds into work, so about 23% for work. And then I used Dr. Gundry's food strategy. I modified it a little bit to kind of fit mine. You see the skip meals and the good fats, improved oils, and cruciferous vegetables at the bottom, the foundation. So, of course, those are going to be the higher percents at 17% and 14%. Being in Arkansas, I love my meat, so I also had grass-fed, pasture-raised meat, even though it's a little bit against his strategy at a 70%. You want to tailor your diet to something that's healthy, but also something that you enjoy. And that's what I try to do here. The meals at 5, 2, 6, and 8, all around the same kind of number, but the percentages really show how much a real percentage is instead of the numbers. It makes it easier to understand. In terms of where I want to live, again, I think this house picture kind of explained it. A nice suburb, maybe in Arkansas, hopefully. Also because the cost of living is lower here in Arkansas than most other places. I think it was interesting just researching how putting these graphs down, putting them into charts makes your goals much more likely in the future. You start to visualize it, start to plan for it, and this is part of the planning here, which is a very good to start doing. It also kind of shows the importance that time management and nutrition management can have. The better you manage your time and nutrition, that's going to affect your financials in a positive way. If you're doing it well, helps you perform better at work, and then performing better at work gives you that money security to focus more time on time management and nutrition. So it's kind of a self-fulfilling cycle there, and a good thing. All right, so that's the end of my video for Excel 1. Thank you for watching. We'll stop it right now.